Alright, so this is assignment 5 for SLHS 1302. For part 1, we have 2 questions. The first one is asking that you assume each die is fair in an experiment of die rolling. When rolling 2 dice at a time, what is the probability of having a pair with identical numbers, such as a 6 and a 6? So it wants us to consider all the outcomes that meet this criteria. So we want to know what the probability would be of rolling 2 1s, or of rolling 2 2s, of rolling 2 3s, or rolling 2 4s, or rolling 2 5s, or lastly rolling 2 6s. So what we would want to do is find the probability of doing each of these things. So we want to know the probability of rolling 2 1s, the probability of rolling 2 2s, 2 3s, 2 4s, 2 5s, and then 2 6s. All right. So to know the probability of rolling 2 1s, we would want to first know what the probability of rolling one is, and the probability of rolling a second one for that die. So if we recall, when we are doing an and in probability, that means we are multiplying two probabilities together. When we are doing an or, we are adding. So we want to know what the probability of rolling 2 1s would be. So we know rolling 1 would be 1 out of 6, and the probability of rolling a second one would be 1 over 6. And then we would multiply those two by each other to get 1 over 36. And so then this would also be the same for rolling 2 2s all the way up to 2 6s. All right, so now that we have the probability for each of these different events, we want to know what the probability of would be overall of having a pair of identical numbers when rolling 2 dice. So in order to do this, we would want to add up all of these probabilities together, because we want to know the probability of this event, or 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 this event. So the answer for this question would then be all of these added up together. So we have 1, 2, 3, 4, 5, 6 over 36, or that can be simplified down to 1/6. So the probability of rolling a pair of identical numbers when rolling 2 die is 1 over 6. Okay, so now for the second question, it says that to assume that each die is fair in an experiment of die rolling. When rolling 2 dice at a time, what is the probability that the outcome of the 2 dice combined will equal 6? So it wants you to assume you're not distinguishing between the 2 die. So that would mean that rolling a 2 and a 4 is the same thing as rolling a 4 and a 2. So the outcomes that meet the condition would be 1 and 5, 2 and 4, and 3 and 3. So that means we would want to know the probability of rolling a 1 and a 5, the probability of rolling a 2 and a 4, and the probability of rolling a 3 and a 3. So we know the probability of rolling a 1 is 1 over 6, and then I also want to roll a 5, so we would multiply because we want both events to occur, so event 1 and event 2. So event 1 being rolling a 1, event 2 being rolling a 5. So multiplying these two probabilities together to get us 1 over 36. And then we know that rolling a 2 is 1 out of 6. Multiply that by 1 out of 6 for rolling a 4, because we want both of these events to occur together. And then same thing for rolling a 3 and a 3. So the answer for this question would then be all of these added together, because we want to know this or this or this, these events occurring, and what the probability of that would be. So you add them all together to get 3 over 36, and that would be your answer for this question. So the probability of rolling 2 die that combine that together combined equal a value of 6 would be 3 over 36. And for question 2, if you want, you can simplify 3 over 36 to 1 over 12. Okay, so for part 3, we're going to install packages for R, and using these packages, we'll be allowed with the following codes to see examples of unique outcomes in coin tossing and die rolling. So we will copy these 2 lines, open up R, get a new script, paste the lines, and run them. And so what these 2 lines are doing is just installing the packages prob and combinate. So if we see here, we see the stop sign kind of blinking, and that just means that those packages are installing. And so we'll want to wait for that stop sign to stop blinking to know that they are done installing. So it stopped blinking, so we're good to move on. So we will go back to the assignment document. And so now we're going to activate the library called prob. And so libraries are just within R. And so this specific library will allow us to do elementary probability. So library prob, we will copy this code line, paste into R, and run. So we'll see that that library is now activated. So now we're going to want to see what the outcomes for tossing a coin once and twice will be. So we will use the code line toss coin, or the function toss coin, to do this. So we will do toss coin 1. So we'll copy that, paste into R, and then it'll show us the outcomes for tossing a coin once. So we see that the outcomes are that you either get a heads or a tails. So now we want to know the outcomes of tossing a coin twice. So we'll copy toss coin 2, paste it into R, and run. And so we'll see that there are 4 different outcomes. For the first outcome, we could get a heads and a heads. Second outcome, tails and heads. Third outcome, heads and tails. And then fourth outcome, tails and tails. And so now let us see what the outcomes would be of tossing a coin 3 times. So copy this code line, toss coin 3, paste into R, and run. And so we see that there are 8 different outcomes. So if we go back to the assignment document, it wants us to paste the output here. So we will copy this from R, copy that, and paste. All right. So now we are going to use the function roll die to see the possible outcomes of rolling a die once and twice. So we will copy this code line here, roll die 1, copy, and then the output will tell us the outcomes of rolling a die 1 time. And so we see there are 6 different outcomes. All right, roll die 2 will allow us to see the outcomes of rolling a die twice. So we'll copy, paste, run that line. And we see that there are 36 outcomes. So now we're going to use these code lines here to see what the probabilities of each of those outcomes are for rolling a die once and rolling a die twice. So we'll copy this line first. So roll die 1, make space equals true. And the output will show us the probability of each of those outcomes. So for rolling a 1, we see that the probability is 0.1666 repeating, and that is the same for each of those different outcomes. And then we will see what the probability is of rolling a die twice, and that we want to know the probability for each of those outcomes. So we'll run this code line. We'll see that for each outcome, the probability is 0.027 repeating. All right, so now we want to find out whether this statement is true. So it says cumulative probability always equals 1. So is it true? Let's find out. So what we are going to do here is create an object that contains the results of that rolling the die twice with the probabilities. So we are going to just name it, for example, I wonder. So you copy this code line here. We will run it in R. And so we'll see over in the global environment that I wonder has popped up. So it's just, we just assigned the rolling the die twice with make space equal true to the name I wonder. All right, and so now we want to find out what the sum of all of those probabilities are for rolling a die twice. So we will do the code line sum of I wonder $prob. So we'll copy that, paste into R, and run. And so we'll see the sum of all of these probabilities for rolling a die twice. So all of these probabilities that we're seeing over here in the console together equal 1. So all of those outcomes for one event will equal 1. So the cumulative probability is 1. And so it wants us to paste the output of this in our assignment document. So we can just copy these two code lines here, or these two things from the console, and paste into our assignment document. Okay, so now we can move on. Okay, so for this question, it wants us to find the probability of getting a 5 for the first roll of 2 rows or a 5 for the second roll of 2 rows. So we can use the OR operator to tell us that we will be adding these probabilities together. So what we can do is we want to know the probability of getting a 5 first in our first roll of 2 rolls. So we would know that, so we'll just type 5 and then anything other than 5. Okay, so what these just mean, it's just a different way of looking at this part right here. So we want to know what the probability of getting a 5 for our first roll would be, and then getting anything other than a 5, or the probability of getting anything other than a 5 for our first roll and a 5 for our second roll. So we know that the probability of getting a 5 is 1 out of 6, and then the probability of getting anything other than a 5 would be 5 out of 6. And then we want to add that to the probability of getting anything other than a 5, which is 5 out of 6. And the probability of getting a 5, 1 out of 6. So the 1 out of 6 is because we want to 5 out of 6, anything other than a 5. And then we multiply them together within each of these different functions because we want to know the probability of getting this and that, or the probability of getting this and that. So multiplication, addition, multiplication. All right, so then we would get a value of 10 out of 36 as our probability, or this can simplify down to 5 over 18. And so another way to get this 10 out of 36 would be to go back to R and look at our output of roll die 2, comma, make space equals true. So we can do that by going back to R and then looking at the values here. So we'll just scroll up to the top of this output here. And so we're looking for anything where we have a 5. So anything with a 5 and anything other than a 5, or anything other than a 5 with a 5. So we see that we got 1 here, 2 here, 3, and we'll scroll a little bit, 4, 5, 6, 7, 8. We're not going to count this one because it is not a 5 with anything other than a 5. It's 2 5s. So we do not count that. So we're only up to 8. Skip that one, 9, and then 10 here. So that is how we get that 10 out of 36. All right. So we can move on now to 3.5. So we're going to use the function cards to look at the probability of getting certain outputs with cards. So we'll copy this code line right here. And simply what we're doing is we are looking at cards and the probability of getting each type of card, and we don't want to know the probability of getting jokers, and then the make space equals true is just to show us that probability of those different outcomes, and then we're assigning it to the name X. So we will copy this code line, paste in R, and run. And so over here we're seeing that we've created that object X in the global environment. All right. And so now we're going to manipulate the data. So we are going to look at a subset of X, and we're specifically going to look at the hearts. So we will copy this and paste into R, run. And so we can see this subset of hearts over here in the global environment. And then if we want to know the output of this object, we would just copy hearts, paste into R, and run. And so we're seeing the output of those different outcomes and the probability of each one. All right. And so now we're also going to create the subset called XYZ and take a look at the content in this object. So the subset is from X, which is just our set of cards that do not contain jokers. And so the subset is just for 7 through 9. So we'll copy this, run, and we'll see that over here, XYZ in the global environment. And then if we want to look at that output of XYZ, just copy that code line, paste, and run. And so we're seeing the outcomes for those different ranks of 7s, 8s, and 9s, or 7 through 9. And so we see it for club, diamond, heart, and spade because we have a 7, 8, and 9 for each of those different types of card. And so we see those probabilities listed over here. All right, and so for 3.5.2, it says assume there are no jokers in the deck of cards. So you draw one card from this deck for 3 times. After each time you put the card back to the deck, what is the probability of getting a diamond card with any number for both of the first 2 cards and a K for the third card? So what we will do to do that is we will want to know first the probability of getting a diamond, the probability of getting another diamond, and then the probability of getting a king for the third card. So we have 1 event, 2 events, and 3 events. So the probability of getting that first diamond card would be 13 out of 52 because we have the 52 cards and the 13 diamonds. And then assume we'll put that card back in. We will then want to see what the probability of getting a second diamond would be. So it will just again be 13 over 52 because we put that first diamond back into the deck. And then the probability of getting a king for the third card will just be 4 out of the 52 cards because we only have 4 kings. And so now what we want to do is multiply all of these probabilities together because we want to know the probability of getting a diamond and then another diamond and then a king. So we would do 13 over 52 multiplied by 13 over 52 multiplied by 4 over 52, and we get an answer of 1 over 208. And that is if we were to simplify 13 over 52 to be 1 over 4, and then 4 out of 52 to be 1 over 13. And that's what gives us that 1 over 208. All right, and so then if you wanted to change this outcome or this probability into a percentage, it would just be 0.0048 or 0.48%. And once again, keep in mind you can be using R to calculate probabilities. So if we wanted to know the probability of all of these together, we would just copy this, go into R, paste, and then run. And then we would see down here that output of 0.0048, which we have here, which then becomes 0.48%. Okay, so now we can move on to part 2 of the assignment. And so we're just going to be using R for this part. So we're going to set our working directory. Here are the code lines for the PC users, and here are for Mac. So what you want to do is you can just copy these lines, paste into R, and then remember it says there's a part where you need to replace with your name or username on your computer, and then you can just run these lines. All right, and then I'm just getting a warning message because I've already created this directory before. Okay, so now that we've created our directory, we can now read in a data set. So this data set comes from this web address right here, and it just contains sound frequency data. So what we will do is we will run this code line right here to read in the data set. And so this code line is just assigning the data set to the name input. So if we look over here, we can see in our global environment that input is listed there. All right, and so now we're going to use the next command line to create an object called sounds. And so this object is just going to contain the contents from the web address that we labeled input. And then it's up to us to decide whether or not we should put false or true for the yellow blank. So we want to determine whether or not the columns in this data set have headers. So what we can do is click the link. And so it brings up this page for us. And so we see that we do have two columns with headers. So the first column is IPA, and so that is just the names of the sounds, and then the count is just the frequency with which we count those different sounds. All right, so then we would, because there are headers, we would replace this highlighted part with true. So we can copy this code line, paste it into R, and run. And so we'll see over in the global environment that object that we just created named sounds. Okay, so if we go back to the assignment document, if we wanted to just look at the first 5 rows of the output of this data set, we would do head, or we would use the function head. And so in order to see it for sounds, we would do head sounds. So copy and paste that line into R and run. And so we see the output for the first 5 rows. And then if we were to go back to the web page for that, we would see that these first 5 rows right here are listed right here. Okay. So now we're going to create a few more objects. So we want to look at specifically the column count from our data set sounds. So we will replace this highlighted part with count. And then so what we're doing here is we're taking that column count from sounds and assigning it to the name X. And so we will run this code line, paste it into R, and run. And so we see over here, X is for the column count. All right, and so now we're going to create another object, and this one will be for the names of those different sounds. So we will replace this highlighted area with IPA. And so what we're doing is we're just taking the column IPA from the dataset sounds and assigning it to the object names of X. And so what that means is that IPA is just those different names for the values from X. And so we will copy this code line, paste into R, and run. And so we'll see over here, if we scroll a little bit, we should see name X somewhere. Not seeing it right now, but it should be in there. All right. Okay. For step 3, we are going to sort the variables for X. So what the sort function does is it just sorts the numbers into increasing order. So we would have lowest numbers at top, highest at the bottom. What we want to do is see it in decreasing order. So we are going to use the function decreasing equals true. So we will just run this code line right here to look at the sorted values for X. Oops. And so we want to copy this line, paste it into R, and run. And so we have X sorted right here. All right. And so now we're going to create an object for the probability distribution plot. So what we will do is we will do X probs equals X sorted over the sum of X sorted. So what that is just giving us is the probability of those sorted values divided by the sum of those sorted values. So we'll copy this, paste into R, and run. And then we should see X probs over here in the global environment. All right, and so then now that we have sorted this data and created the found the probabilities for those sounds, we are now going to create space for 2 plots. So we want to have 2 plots in one column. So we will copy this code line right here, copy, paste into R, and run. And so we've just set it up in the plot area so that we'll be able to have those 2 plots in there. All right, and so now we want to have a bar plot for our X sorted. So we will copy this code line, paste into R, and run. And so we'll see that bar plot over here. And so we're just seeing those values in decreasing order, so greatest frequency to lowest for the different sounds. All right, and now if we wanted to draw a box around the plot, we just use the function box, copy that, paste into R, and run. And so we'll see that box pops up over here in the plot function. All right, so now let's give a title to this plot. So the title will be Frequencies of English Sounds in MHR Study. We're also giving labels to the X axis and y-axis. So x-axis will be those sounds, and then y-axis will be the frequency with which those sounds occur. So we'll copy this code line, paste into R, and run. And so here we see the title and then the labels for the x and y axis. All right. And so now we want to create a bar plot for the probabilities of English sounds. So what we will do is we will then want to replace this highlighted area with that x probs that we created earlier. All right, so we will just copy this, paste into R, and run, and then we should see that second box bar plot popping up down here. All right, and then if we wanted to draw a box around it, we would copy box, paste, and run, and we see the box popping up around our bar plot. And then we want to give it the title, Probabilities of English Sounds in the MHR Study. X lab is sounds, and then the Y lab, just like with the last bar plot, will be probability. So it's meant to represent the values with which we're looking at. So for the other bar plot, we were looking at the frequency with which those occur. And now that we're looking at probability, we're looking at the probability with which those values occur, or with which those sounds occur. So we'll run that. And so here we're seeing probabilities of English sounds in the MHR study. We have sounds on the x-axis and then probability on the y-axis. All right, and so now we want to save this image, so we will copy this code line, paste into R, and run. And then also this code line, copy, paste, and run. And then we see here that it wants us to insert our graph. So you can do this however you prefer. Export, save as image is what I typically do. And then I like to save to my desktop. All right, save. And so then insert the graph. And this is what you should be seeing. If you were to actually expand the plot area in R, you would see a more detailed plot, which would give you more of those sounds that you're seeing. But if you have yours in a smaller plotting area, that's fine too. All right, so now that we're done with this part, we can move on to step 7. So for this step, you will assume that you're playing the Phonetics Wheel of Fortune game and that you have learned the proper strategy to play the game. So there are 20 empty slots on the board. Given the probability distribution of sounds in the MHR study, you want to calculate the probability of winning the bet if you bet on the most frequent sound for your first try, and this sound being T. So you're given 2 hints here. The first hint says since you either win or lose, you can use the function that you're given here. So it is the probability that you win equals 1 minus the probability that you lose. And then for hint 2, it says enter x probs in R to find the probability of the T sound. So this is where we will start. So we will take this code line right here, copy and paste into R, and we will run that to find the probability of T. And so we see that value right here in the console. So we can just copy this value, go into R, and then save it for our reference. And so now we want to use this equation right here. So what is the probability that you win? I'm given 1 minus the probability that you lose. So we will say probability that you win equals 1 minus the probability that you lose. So the probability that you lose would be 1 minus the probability of you getting a T, which is 0.079. So the probability that you lose is just the probability that you're not getting this T. And so then we have 20 empty slots on the board, so that means there's 20 chances. So we'd want to do it as a function or by the power of 20. So we can run this in R to see what the value would be, or our output. And so we're getting an output of 0.807. So we'll copy this and that would be our answer. So the probability of winning the bet, if you were to bet on the most frequent sound for your first try, would be 0.807. And so another way we can do this is by going into R and doing 1 minus dB INOM. And so what this function is just for is finding the probability basically of you losing. So we would do 0, 20 because there are 20 spots. And then the probability of getting a T, which is 0.0798378013. And then we can run this. And we see here that we get a value of 0.81, which is very similar to our value that we got by manually calculating it of 0.807. And so the answer you need is just 0.807, or if you were to do the 1 minus dB INOM with 0, 20, the probability of T, which is 0.79, with the output being 0.81. So you can either have this or this as your answer. It doesn't matter. All right, and so then lastly, we're going to want to save a history. So copy this code line and paste into R and run. All right, and then if you wanted to further understand what this function means right here, you can just copy the name, go into your help bar, and then search it. And so we're seeing that it's for binomial distribution. What the first value mean, it's x, so it is just the vector of quantiles. The 20 stands for size, which is just the number of trials. So if we remember in our assignment document, it said that we had 20 empty slots on the board. Oops. And then the prob is just the probability of whatever it is you're trying to get, which was T, which had a probability of 0.079. All right, and so just to go through the assignment and what you need to have in here before you submit. So you would want your answers to questions 1 and 2. For question 1, you would have 6 over 36 or 1 over 6. Question 2, you would have 3 over 36 or 1 over 12. And those are each worth 1 point. And then you would want the output for your toss coin 3. So what are the outcomes of tossing a coin 3 times? You would want to have that. You should have 8 rows, 3 columns. All right. Then you would have your output for sum of I wonder prob. So what is the output of the probabilities for I wonder? We got a sum of 1. All right. And then you would want your answer for what the probability of getting a 5 on a first roll and anything other than a 5 on a second roll, or if anything other than a 5 on your first roll and a 5 on a second roll. And so we got 10 over 36 or 5 over 18. And so that would be another point. And then you have one more point for answering this question. So assuming there are no jokers in the deck of cards, what is the probability of getting a diamond card on both of your first 2 cards and then a king on your third? And then you want to also consider that you are replacing these cards back into the deck, so you will always have 52 cards to pick from. And so you want to multiply all of these probabilities together because we want all of these events to occur at one time. So we are getting a probability of 1 over 208, which equals to be 0.0048 or 0.48%. All right, and then for part 2, application using R, you will get half a point for filling in this blank for true, this blank with count, this blank space with IPA. And so each of those are worth half a point. Another half a point for filling in this space with X probs, half a point for filling in this with probability, half a point for both of these graphs right here in the same plot, and then 1 point for the probability of winning the bet if you were to bet on most frequent sound T for your first try. So you can either have your answer be 0.807 or 0.81, whichever you prefer. And then you can do either one of these methods to obtain that value. This one is just you calculating it manually. This part is a code line that you would insert into R. And then remember, you can find this probability of t by using this code line right here to see the probabilities of each of those different sounds. And then that is it for this assignment.